Hello. Can you hear me? Just say something. Say hi. Okay, perfect. Good. Very nice. Before we start, maybe some burning questions about the course, about submitting work. Do you all know where you submit the work? Do you all have groups? So as of now, we have a short, well, we have about a waiting list of about 10-15 people who are waiting to be assigned to groups. So if you haven't received a message that you're if you have received a message that you're accepted, but you haven't been sent a message to join a group yet, so don't worry, this will happen in the next few days. Just can carry on doing the work, attend webinars, and we'll find a. Do you have group work on top of this weekly Tuesday streams? Yes, Tuesday weekly stream is for everyone. Even if you're not accepted to COMPOS, you are still welcome to come and join the webinars. Now the group work is separate. Okay. Okay. I think you see. Yes, Ben, you're in my group. As a matter of fact, I will be taking a group this year, and so it looks like the webinar is going to be Friday at 5 o'clock. Okay, can't promise that I'll be your tutor for the whole year, but yeah, it's for some time at least. As long as you can, as long as you contact your tutor and let them know that you have had an extension, you won't. Don't worry. We will send you lots of messages before removing you from the course. Right. Okay. So today I want to talk about differentiation, and you probably have seen the sheet. You probably didn't have enough time to do any problems, but today differentiation, differential calculus to be precise. So Ahmed, as I said, there are about 10 people in the waiting list. Perhaps you're in the waiting list. If you're not sure, just email compos.oxford@gmail.com and ask. We monitor this. No message will go unanswered, but it might take some time to answer. So sorry. There's a lot of communication right now. Right, so differential calculus and or differentiation. Or simply put, derivatives for today. Okay. We have another option on Saturday, so I'll try to accommodate everyone. Right, so I'm gonna share my screen. Okay. If you don't see my screen, let me know. Chat. Okay, so differentiation. What is a derivative? So have you studied derivatives and derivation? Have you studied derivatives at school? 1 for yes, 0 for no. Okay, just maybe 1 or 2 zeros, a half. Okay. Well, the world is not black and white for Vin. Good. Okay, derivative. So I'll just a recap. So if you have a graph of a function, You have a graph of a function, and this is a graph, and the function is f of x. The derivative tells you how quickly the function is changing. Okay. And it might sound confusing. What does it mean? How fast a function is changing? Well, I'll give you an example. For example, S is displacement. And how quickly the displacement is changing is what? How quickly the displacement is changing. How do we call that in physics? Yeah, velocity, absolutely. The rate of change of displacement. So how quickly it changes. So ds dt is how quickly s is changing. I would accept its speed, by the way, but obviously you are correct. It's velocity. How quickly it is changing, and it's also known as velocity. Velocity. So velocity is the derivative of displacement. That's an example. So how quickly something is changing. So how quickly is a coordinate changing? How quickly is a size changing? How quickly something is changing. Right. On the other hand, we can draw. Okay, let's find how quickly the function is changing at point x. To understand how quickly it is changing, we move along the curve a small distance, and let's call this distance delta x. So I've moved from x horizontally to a point called x plus delta x. So I've shifted slightly, delta x. Now here, this is f of x. This is the function at point x. And this is a function at point x plus delta x. And we will call this amount. So do you understand what I've done so far? So I started at point x. I've moved a little bit to the right along the graph to a new point with coordinates x plus delta x and f of x plus delta x. Okay, if it's not clear, let me know. Type a 0 if you don't understand. Okay, we will call this distance, we will call change in x. Well, and it is change in x. And this we will call change in y. This is change in x, and this is change in y. And if we draw a line, then the gradient of that line, is delta y divided by delta x. So I just found the gradient of the red line. Okay, is delta x over delta y. But we know that delta y is this minus this, this minus this. So f of x plus delta x minus f of x, and delta x, well, delta x is delta x because it's x plus delta x minus x, so which makes it delta x. So this expression is simply the gradient of the red line. And I want you to be really really solid in the understanding that this is the gradient of the red line. Are we all clear? How well do you understand on a scale of 0 to 10, please? Good. Very nice. Now, what I'm going to do is I'm going to make this step smaller, making the initial step smaller. So what happens? Well, the line becomes, so instead of going here, we go here, and the line goes like this. I'm just gonna draw this. I'm just gonna draw this separately. If you have a curve and you start from here, you make it smaller, 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 smaller. So you're moving from here to here to here to here to here. And at some point, you get a line which is tangent to the curve at this point. Tangent line. So as this is the tangent, as making these the red line gets closer to the tangent. And we say that the gradient tends to the gradient of the tangent Basically, the derivative is the gradient of the red line as the step becomes progressively smaller. Now, the derivative, so the dy dx, of course, at point x, is equal to the limit of f of x plus delta x minus f of x divided by delta x as delta x tends to 0. So as delta x tends to 0. And if you look at the notation, this is the same as writing because this expression is delta y over delta x. We can also write this. So dy over dx is the limit of delta x tends to 0 of delta y over delta x. Look at that. This is not a coincidence, because d in calculus means infinitely small change. So delta means change. D means infinitely small change. Okay. Infinitely small change. And that's why you see this expression is almost the same as this one. Any questions? So the definition, well, I'll just delete that x. It's just derivative. This is the definition of a derivative. When they ask you to define Well, integration is a slightly opposite thing, is opposite to differentiation. Does this mean differentiation is approximation rather than approach to achieve the exact answer? No. It does not give you, it is not an approximation. You can use derivatives to approximate, but the derivative itself is not an approximation. It's because you're finding the limiting value. Okay. Can we cancel out delta x as it tends to 0? What do you mean? Can you? Depends. Like here, well, delta y also tends to 0 and delta x tends to 0. So you kind of get 0 over 0. Look, to understand why the why derivative is not an approximation, consider the following example. We take a glass, and the glass is can hold up to 400 milliliters of water. So it's a 400 milliliter glass of water. We put into the glass 0.3 liters. So 0.3 liters. Then we add some more water. So we add some more water. In fact, we add 10 times less, 0.03. If you want y equals x to the power of x, I'll get back to that, Ben. So 0.3 plus 0.0, so you add some more water. You add 0.03 liters of water. Then you add 0.003. And you keep adding water. You keep adding water forever. If we weren't limited by the size of an atom, we could do it infinitely. We can add water to the glass infinitely many times. And what is the total amount of water after we do this infinity times? What is 0.3 recurring? Yes, is 0.3333, but in fact 0.3 recurring is 1/3. Now, if you do n times, you get closer and closer to 1/3. You never actually reach 1/3, but the maximum amount of water that you can have is exactly 1/3. So even though every step is an approximation, is a better and better and better approximation, the final value, which is the limiting value, is exactly 1/3. I don't know if that helps. I don't. Hopefully it does. You could have a series of approximations leading to an exact value, because every time you do, it's an approximation. It's 0.3. The next approximation is 0.33, 0.333, 0.3333, etc. And finally, you get 1/3, which is exact. All right, to do this one, this is a tricky one. You need to get creative, and you need to understand that x can be written as e to the power ln x. And then it becomes e to the power x ln x. And now you can differentiate. Okay. This is an interesting one. Actually, I was I remember this one because when I went to university, I was in my first year, and you know, sometimes in toilets you have rude words written. I remember when I walked into the toilet, it was written y equals x to the power x. Find the derivative. I was like, okay, I'm in the right place. Okay, not that I approve vandalism, but at least it's that kind of vandalism. Right, so getting back to this, find the derivative of y equals x to the power 5 from the first principles. Okay, so let's try to construct this. So we have the definition. We have the definition, and we'll just try to untangle it. So f of x, let me use blue. F of x is x to the power 5. That means f of x plus delta x is x plus delta x to the power 5. And yeah, so what I need to do is I need to dy over dx is the limit as delta x tends to 0 of the following expression of this minus this, x plus delta x to the power 5 minus x to the power 5 divided by delta x. Now, you might have studied binomial expansion. You might have not. But anyways, you can expand x plus delta x to the power 5. You can expand as x to the power 5 plus 5x to the power 4 delta x plus 10. Is it 10? 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 5, 10, 10, 5, 1. Yes, 10x to the power 3 delta x squared plus 10x squared delta x to the power 3 plus 5 delta x to the power 1 delta x plus delta x to the power 5. Yes, thank you, Alistair. So yes, I mean, you could do it by hand. It just takes a long time to do this by hand. I hope you all understand how I do it. There are many ways of doing it, but if I do it minus x5, so you can see x. So I'm going to be even lazier. Just going to copy that across. Okay. Minus x to the power 5. So cancel the x to the power 5, divide by delta x. And as a matter of fact, I have limit delta x to the power tends to 0, divide, so it's going to be 5x to the power 4 plus 10x cubed delta x plus 10x squared delta x squared plus 5 x delta x4 delta x3 plus delta x to the power 4. Yes, thank you, to the power 4. And where did I lose the delta 4? But then delta x tends to 0. So this thing becomes 0. This thing becomes 0 because it's multiplication by 0. This becomes 0 and this becomes 0. And I'm left with, so the limit of this expression as delta x tends to 0 is 5x to the power 4. Beautifully done. But you also know the formula. You know that x to the power n, the derivative is n x to the power n minus 1. So that's that is it. I mean, x to the power 5, derivative is 5x to the power 4. So this is how you find things from the first derivative, from the first principles. And let's do the sine one. Now I'm gonna do this, but I'm gonna cheat a little here, but hopefully you'll forgive me, because can you prove the power rule? Well, that's you do the same thing, just instead of 5, you've put n, and I mean, the only thing you can't do is the full expansion, but you don't need the full expansion, so you can just replace with 5. How do we prove it for non-integer powers? Well, you still have a binomial expansion for non-integer powers. You use this binomial expansion for non-integer powers. Yeah. Yeah. So, Volodymyr, yes, you just yeah, use the formula. Just look it up. Binomial expansion for non-integer powers, and you can have binomial expansion for any power. No, it there's a separate formula which they hide from you, not to scare you off in year 12. So binomial expansion formula, and here it is. The second one. The first one, it only works for integers. The second one works for any power. So let's say we had 1 plus b to the power 1/2. It would be 1 plus 1/2 b plus 1/2 multiplied by -1/2 times b squared over 2 factorial plus etc. It's just going to be infinitely long. That's the thing. Yeah. Oh yeah. Sometimes you sometimes do. I mean, why, if you learn the first formula, why not learn the second one? The only limitation is that the first number has to be 1, and you just need to modify your numbers a tiny bit. So you do, yeah, you take x out of the brackets. Okay, is this true for I? For complex numbers, you mean? Yeah, I believe so. I believe it works for complex numbers as well. All right, find the derivative of sine x and sine 4x from the first principles and compare the gradients. Okay, so we have f of x equals sine x. And we have f of x plus delta x is sine x plus delta x. And because you're so good at trigonometry now, you can expand this as sine x cos delta x plus cos x sine delta x, and you plug that in. So the derivative dy over dx is the limit as delta x tends to 0 of sine x cos delta x plus cos x sine delta x minus sine x divided by delta x. Okay, and you got cos x, so I'm writing this one separately, cos x sine delta x divided by delta x plus sine x cos delta x minus sine x divided by delta x. And here we have cos x multiplied by sine delta x over delta x. So I'm separating cos x and sine x plus sine x, open bracket, cos delta x minus 1 divided by delta x. Right. Well, this is where I need to cheat a little. Basically, there's such a thing as small angle approximations. Okay, because I know, oh, the limit, sorry, limit, thank you, delta x tends to 0, limit delta x tends to 0. The small angle approximation. So if x is small, sine x is approximately equal to x, and tan x. So because delta x is small, sine delta x is approximately delta x. And there's another approximation, cos delta x. So that's the first small angle approximation. And the second small angle approximation is that cos x is approximately equal to 1 minus x squared over 2. So cos delta x is approximately 1 minus delta x squared over 2. And I plug that in. So it's the limit cos x delta x. Oh, that's delta x over delta x, so that becomes 1. Cos x plus sine x, and this becomes 1 minus delta x squared over 2 minus 1 divided by delta x. So 1 cancels, delta x cancels, and you have limit delta x tends to 0 of cos x plus sine x multiplied by minus delta x over 2. Sorry for being so messy, but this is 0. And the limit is cos x. So the derivative is cos x. Now, why am I cheating? Well, because I haven't proved the small angle approximation formula. Exactly. Yes, Risen, you've spotted me cheating. The small angle approximations comes from the Maclaurin series, and the Maclaurin series is defined through the derivative. Okay. Now there is a geometric reasoning for the small angle approximations. It's just I don't have enough time to go through them, but there is a geometric reasoning. So believe me when I say that this can be proved geometrically using a circle, and you can prove that. No, Ben, 0 divided by 0 is undefined, as is anything divided by 0. So yes, 0 divided by 0 is undefined. But the limit of the ratio of two functions that tend to 0 can be a real number. Now, we found that the derivative of sine is cosine. Well, I mean, yes, we already knew that. At least I believe you knew that. But the interesting bit is the next one. We need to find the sine 4x, and in a similar fashion, we can find the derivative of sine 4x. So I'll try to do this quickly, just not to spend too much time. So difficult. You have such a big choice. So dy over dx. So if y equals sine 4x, this is the limit. Delta x tends to 0. Sine 4x plus 4 delta x, it's going to be minus sine 4x divided by delta x, and okay, so that's going to be cos 4x multiplied by sine 4 delta x divided by delta x plus sine 4x cos 4 delta x minus 1 divided by, it's going to be the same thing, divided by delta x. We already know in the limit, of course, delta x tends to 0. Already know that this tends to 0, so this thing goes away. And now this thing. Now what to do with this thing? With this thing, well, we could sine 4 delta x. Well, sine 4 delta x is approximately 4 delta x. So sine 4 delta x is approximately 4 delta x. So this tends to 4. This becomes 4 cos 4x. Because sine 4x, so f of x is sine 4x, f of x plus delta x. You replace x with delta x, so it's going to be sine 4 multiplied by x plus delta x. which is 4x sine 4x plus 4 delta x. Does that answer the question, Aman? Okay, good. I'll delete that. Just those of you who watch it, that's fine. Okay, so it is recording. That's good. I was afraid. Now, what does it actually tell us? Well, let's sketch those. You know, the big and mighty Desmos. Y is equal to sine x. Y is equal to sine 4x. It should be familiar to you. Right, let's look at sine x. So this is sine x, and this is sine 4x. If you look at the gradient of the red line, and you look at the gradient of the blue line, you see the gradient is 4 times greater. The gradient is 4 times greater. This is because y is equal to sine 4x, and y, the derivative, is 4 cos 4x. So you can see that when you find the derivative becomes 4 times bigger. Okay, because the derivative is the gradient, and the gradient is 4 times bigger than that. So, or the maximum value of the derivative is 4 times the initial value. Okay, the maximum value for the derivative is 4 times greater. Yeah, it's the amplitude of the derivative is greater. Yes, the amplitude of the derivative. And yeah. Now, just for the future, a very common task, for example, on any PAT or MAT exam, is you're given a derivative, a graph of the derivative, and you need to find the graph of the function. Okay. Like for example, you have a graph of the derivative, which is unknown. Let's do this as problem 9, problem 8. Problem 8. 8. Given a graph of f of x, find sketch the graph of f of x. And they will usually say assume f of 0 is 0. Now the last bit is kind of important, but does f of x so Ben, for the purpose of calculation, yes. Whether you've written a correct statement, no. Okay. Because what you've written kind of doesn't make sense. because f strife of ax is not equal to a times f strife of ax. I hope you see what I mean. But neither this is true. um, is it af strife of x? Well, not really. Not really. It's not that easy, but no, I perfectly understand what you mean. Yes, it's just incredibly difficult to write it in the correct way. Anyways, you've given a graph of f strife of x, and you have x and y. Okay, so let's say you are given a graph. Like this, okay? And you need to sketch a graph of f of x. So this is f strife of x. So how do you approach this problem? So the derivative is, first the derivative is positive and it's constant. So constant derivative, positive number. And we know that f of 0 is 0. That means we start from here. We start from 0. So this is f of x. This is f strife of x. And this is x. So first it's positive and constant. So that means it's a straight line going up. Going up. Then the gradient decreases to 0 because this is the gradient. This is the gradient. So constant positive gradient, that means constant positive gradient, then the gradient decreases to 0. So slowly the gradient decreases to 0. Takes about 3 squares. Like this. Gradient decreases to 0. Now we have 0 gradient here. And then the gradient becomes negative and increasingly negative. So it goes like this. Okay. And this is f of x. So you know nothing about the formula. Of course, if they give you the formula, that would be incredibly easy. So for example, this line is y equals 4. Yeah, y equals 4. And this is y equals 4x. And this gradient of the derivative of 4x is 4. So it works. But they don't give you that. And they love these questions on Oxford admissions. They love these questions on PAT and math. So practice. This is a really cool skill. Okay, all the cool kids are doing it. Okay, Find the derivative of sine squared x. Now, of course, you could use the chain rule here. Yep, chain rule, simple. If you know it, chain rule. And you have sine x squared. And you need to find the derivative of that. So you treat it as a function. So the logic of the sine rule is that you treat you basically make a substitution. U equals sine x. So what would it be if it was u squared derivative? Well, it's going to be 2u. But then, because of how the chain rule works, you have to multiply that by the derivative of u strife. So what am I talking about? Dy on dx is equal to dy on du multiplied by du on dx. So y prime is equal to dy over du, so y prime with respect to u, multiplied by u prime. So if u is sine x, then u prime is cos x, then y is sine x squared, so which is u squared, and the derivative of u is 2u. So it's if it's u squared, it's 2u multiplied by u prime. How well do you understand what I've just done? On a 0 to 10, don't be shy. Most of you probably haven't studied that before. Okay. Right. Yes. But that's the thing. We haven't studied the chain rule, and once you learn about the chain rule, this becomes super easy for you. Chain rule. So do read about the chain rule, because today that's not what I wanted to do. And if you do this, so 2u, so it's going to be 2 sine x multiplied by u prime, which is cos x. Because what I wanted to do is actually avoid using the chain rule without chain rule. So what can you do without the chain rule? Well, sine squared x can be written as sine x. Well, it's sine squared x. Full stop. Then we remember a formula from the previous assignment, that cos 2x can be written as 2 sine squared x minus 1. So from here, cos 2x plus 1 equals 2 sine squared x. In other words, sine squared x is equal to 1/2 cos 2x plus 1/2. We usually write it the other way around. We say it's 1/2 plus 1/2 cos 2x. And we need to find the derivative of that. So sine squared x, the derivative, is the derivative of this, 2x. The derivative of a half is 0, plus the derivative of cos. And we already know that the derivative, if the derivative of sine x from the previous result, we know that the derivative of sine x is cos x, and the derivative of sine 4x is 4 cos 4x, and nothing is wrong with saying that sine nx is n cos nx. A similar reasoning can be applied to cos. Cos x, derivative of cos x, is minus sine x. Cos 4x is minus 4 sine 4x, and cos nx is minus n sine nx. In other words, it's going to be 1/2. The 1/2 doesn't change. Cos 2x. Cos 2x, we use this formula. So it's going to be minus 2 sine 2x, which is 1/2 times minus 2, which is minus sine 2x. And where did I mess up? And here, the chain rule. No, you can do it without the chain rule. You can do the assignment, but overall, yes, there's some videos on the chain rule. No, sorry, I've messed up completely here. This is wrong. Now you have done the trigonometric assignment. You should know better. Right. Cos 2x is 1 minus 2 sine squared x. So sine squared x is equal to 1/2 minus 1/2 minus 1/2 cos 2x. Okay. And here it becomes 1/2 minus, so there's a minus, so that's plus sine 2x. Now, how does this compare to that? How does this compare to this answer? Well, as a matter of fact, we know that sine 2x is 2 sine x cos x. Okay. Right. Okay. Trigonometry, not the easiest thing in the world. Hopefully you've it doesn't matter. Sine 2x or 2 sine x cos x, that's the same thing. Okay. The product rule. So we have the product rule, the quotient rule, and the chain rule. You do need to know. Sorry. A couple of minutes ago I said you can do it without the chain rule. Not really. You do need to know the chain rule. the product rule, the quotient rule, and the product rule says that if you have two functions, u multiplied by v, and you want to find the derivative of those, you simply find the derivative of the first one multiplied by the second one plus the first one times the derivative of the second one. How does this work? Well, for example, you have sine x multiplied by x cubed, and you want to find the derivative. So this is the first function, this is the second function, this is u, this is v. So you do derivative of the first one, so sine x multiplied by x cubed plus sine x multiplied by x cubed prime. This is called the product rule. Product rule. Do you understand the product rule on a scale of 0 to 10, please? Yeah, the product rule is the easiest one. Yes, very, very good. So we're going to use the product rule to find this. So we need to find the derivative. F prime is the derivative, well, f prime of x. So we have the derivative of that, x squared minus 3x prime multiplied by x cubed minus 8x plus x squared minus 3x multiplied by x cubed minus 8x prime. So that is 2x minus 3, x cubed minus 8x plus x squared minus 3x multiplied by, so this is 3x squared minus 8. And now we expand. So 2x to the power 4 minus 16x squared minus 3x cubed plus 24x plus 3x to the power 4 minus 8x squared minus 9x cubed plus 24x. So 5x to the power 4. Are there any cubes? Yes, minus 12x cubed. 16 minus 8 minus 24x squared plus 48x. Phew. All right. Let's try a different method. The different method would be to simplify f of x first. So that's the first method. We just open the brackets, x to the power 5 minus 8x cubed minus 3x to the power 4 plus 24x squared. And using the second method, we find the derivative. It's going to be 5x to the power 4 minus 24x squared minus 12x cubed plus 48x, which is the same. Well, I kind of feel like the second method is easier. I hope you agree with me. You just open the brackets and you find the derivative. But we've proved, well, we've shown, not necessarily proved, but we've shown that the product rule works for this particular case. Right. Now, it's no use. I do want to show you the chain rule again and how to use it, because I feel that The chain rule is actually much easier than you think. So the product rule. So let's do the quotient rule as well. Quotient rule. For the quotient rule, you have u divided by v. So if you have the division of two functions, it's u strife v minus uv prime, uv strife, over v squared. So for example, if you have sine x divided by cos x prime, it's going to be sine x prime cos x minus sine x cos x prime divided by cos x squared. Do you understand how to use the quotient rule on a scale of 0 to 10, please? So it's the derivative of the first one times the second one minus the first one times the derivative of the second one divided by cos x squared, but divided by the second function squared. And now the chain rule. The chain rule. Chain rule. Chain rule is the toughest to understand, but once you get it, you really start appreciating it. And these are the only 3 rules of differentiation. We won't have anything else. That's the beautiful thing about differentiation. And sorry. That's the beautiful thing about differentiation. So the chain rule. The chain rule is when you have a function, you have a composite function. Composite function. When you have f of g of x, the derivative of f of g of x is the derivative f with respect to g multiplied by the derivative of g with respect to x. That's the short way of writing it. Of course, it can be written as df over dx is equal to df over dg multiplied by dg over dx. This is another way of writing it, and as you can see, dg cancels and you have df over dx, so which is the same as here. But we do this when df over dx is not possible to find, but df over dg is possible, and dg over dx is possible as well. So how does it work? Let's say you have a function inside a function. Let's say you have sine x plus x squared to the power of 7. We call this the inside function. Inside. And this is the outside. Outside. Here, this is the outside, and this is the inside. So to find the derivative of y, we first find the derivative of the outside function. Okay? What does it mean? Well, we treat the inside as a single variable. So we can say that this is g to the power 7. Yeah. And the derivative of the outside function. So this is the derivative of g to the power 7. Multiplied by the derivative of the inside function. multiplied by the derivative of sine x plus x squared. So the derivative of the outside function times the derivative of the inside function. And this is 7g to the power 6 multiplied by derivative of the outside function. So cos x plus 2x. In other words, y prime is 7 sine x plus x squared to the power 6 multiplied by cos x plus 2x. So derivative of the outside function multiplied by the derivative of the inside function. I'll do another example. Y is equal to sine, just make it simple, sine x to the power 8. Sine x to the power 8. To find the derivative, you just treat it as g, something to the power 8. So it's 8 sine x to the power 7. And then just multiply by the derivative of the inside function, which is cos x. Super easy. Chain rule is easier than you think. Did you understand the last example on a scale of 0 to 10, please? Okay. Now, just another small vote. If you now before if you didn't know how to do this before, oh wait, it doesn't make any sense. If you sorry, I'm overcomplicating myself. If you didn't know how to do this before and now you do, can you type 1, please? Now, if you knew this already, type 2. Okay. Good. And if you still don't understand how to do this, type 0, please. Don't be shy. I don't bite. Five-ish. Okay, I'll just do a quick one more example. Let's say we have y, and you have something. Let's do the opposite way. Sine of x cubed minus 7x. So now sine is the outside function. Sine is the outside, and this is the inside. So to find the derivative, you find the derivative of the outside function. The derivative of sine is cosine. So it's cosine x cubed minus 7x multiplied by the derivative of the inside function, multiplied by 3x squared minus 7. And that's it. Okay. Like CM, is it better now? Is it still 0.5? Okay, better. Good. So you have 3 rules. And meet Mr. Crocodile. So this is Mr. Crocodile. Mr. Crocodile. because it looks like this, and look, it looks scary. And actually, this is it. Well, this is a similar question. This is university. This is my university. Sorry, the university I went to. It's MIPT, and this is what they did on the first test. This was the first test. Well, this was 2015. I went to university in 2003, but regardless, they give the same test every year. This was the question. And they call it a crocodile. Then why is it a crocodile? It's huge and massive, and what on earth do you do with it? But as a matter of fact, if you know the rules, it's only 3 rules, you can do it. So we're not gonna do this one, but we are going to do this one. I'll do it. I won't go through the details, but I'll just point out what I'm using. So first we have, nope. First we have the square. The square is the outside function. Yes, so that's the outside function. So to find y, we have 2 multiplied by that, 6 cos x squared minus 2x divided by x sine x to the power 1. Well, we don't need that. Multiplied by the derivative of the inside, multiplied by the derivative of 6 cos x squared. Yes, sh is hyperbolic sign. We called it shinus or shinus. 6 cos minus 2x divided by x sine x. Now you just need the derivative of this. So this you don't touch, you just need the derivative of this. And this is a quotient rule. Yeah, because it's a division of 2 functions, so it is a quotient rule. So we copy this down to, actually copy that. Multiplied by, so this is the top and bottom. So the derivative of the top, 6 cos x squared minus 2x x sine x minus 6 cos x squared minus 2x multiplied by x sine x prime x squared sine squared x. You see, we've got the answer except these bits. We only need this and this. So let's do that separately. 6 cos x squared minus 2x. If you want to find the derivative. Now this is another chain rule. So it's 6 sine minus 6 sine x squared multiplied by the derivative of the inside, 2x minus 2, and oh yeah, that's it. And x sine x. What kind of rule is this? Help me, please. X sine x. Product rule. Yes, well done. So it's going to be 1 multiplied by sine x plus x multiplied by cos x. And all you need is just to plug that in. Plug that into the original one. So we copy this. Copy this and just modify. So this becomes minus 12. 12x sine x squared minus 2 and sine x plus x cos x. And this is the answer. They said you do not need to simplify the answer. Do not simplify the answer. And it actually says here, you do not need to simplify the answer. But the beautiful thing is that no matter how difficult the function is, no matter what kind of crocodile they give you, it all breaks down into 3 rules: product rule, quotient rule, and chain rule. And this is why differentiation is simple. Like they teach differentiation in, I don't know, 2 weeks at university. They spend 2 weeks teaching differentiation, and they spend 3 years teaching you how to integrate. And after 3 years, very few people can actually say, now I'm good at integration. Okay. So differentiation is just following an algorithm, like quite a simple algorithm, and integration is an art. Is definitely a form of art. Okay. Problem 6. Problem 7. Okay. Problem 7 is super important. So I'll just quickly go through problem 6. Find equation of a straight line which is tangent to the curve this in 2 distinct points. Well, there are different ways of doing it. There is a way of doing it analytically, but if I do this analytically, it's just a lot of calculations. I've done them here today. It took a whole page. It's not that difficult, but if there's a shortcut, why not take it? It says a straight line which is tangent to the curve at 2 distinct points. Okay. So, well, first thing we need to do is to draw the curve. So what is the curve? So y is equal to x squared minus 2 modulus x minus 1. Well, we need to know what modulus is. Modulus. We know that modulus of x, by definition, is x if x is positive, and it's minus x if x is negative. That's the definition of modulus. Definition. So modulus x minus 1 is equal to x minus 1 if x minus 1 is greater or equal to 0, and it's equal to minus x plus 1 if x minus 1 is negative. And you can simplify that further. Modulus x minus 1 equals x minus 1 if x is greater or equal to 0. It's equal to minus x plus 1 if x is less than, oh, sorry, not 0, 1, of course. 1. And you plug that into here. Y is equal to x squared minus 2x plus 2 if x is greater or equal to 1. Or it's equal to x squared plus 2x minus 2 if x is less than 1. So it's it's a piecewise function. It's a piecewise graph. So what you do is you draw them both. So this one, it's going to be plus, so 2, 2, 2 plus 2. So the graph is going to be like this. And this graph is going to be like this. And basically, from 1, you will have, you go along this graph, and then you go along this graph. So this is your final graph. Because for when x is greater than 1, so this is 1, for x is greater than 1, it's one curve. And if x is less than 1, it's another curve. And we can use our good old friend Desmos. Y is equal to x squared. Is it plus? Minus. Minus modulus of x minus 1. Look at that. Just as predicted. Although there's a very subtle change. It's a very subtle change. So let's just clarify what we have drawn. Y equals x squared minus x plus O. Is it 2, right? Yes, 2x plus 2. And y is equal to x squared plus 2x minus 2. Look, what we had is we had two graphs, and then we take this up. We take the black graph up to 1, so only this bit, the green bit. And then we take the second graph, but only starting from 1, and that's how we got the two pieces. And now all we need to do is to draw a straight line, and y is equal to x. Okay, that will never touch the graph in two distinct places. How about 2x? Looks decent. Minus 1, minus 2. Ooh, fantastic. Y equals 2x minus 2. I cheated a lot, but it works. Not that I would accept such an answer, but it is a way. Well, I mean, if you can show that that's the only way, if you can prove that it's the only way, I would be happy if you do it this way. Okay, it's two distinct points, so it is a tangent, and if you're interested, well, I don't have the explanations here, but maybe next time I can talk a little bit about that. Just don't overload this session with the algebra. Now this one is super important. What are the dimensions of the largest rectangle that can be placed in the triangle above? Now this is called this is a optimization problem. What is the biggest rectangle you can place? So let's try drawing it. Well, it could be like this, could be like this, could be like this, probably something like this. Because if now like this, the area is 0. Like this, the area is 0. So somewhere in between, somewhere in between, the area is maximum. And let's say that the size of this rectangle is x by y. X by y. And So this is y. This would be 24 minus x, and this would be 18 minus x. So first, let's find a proportion. So the tangent of this angle, you can use tangent theta. You'll see in a minute why I'm doing tangent. 18 minus y, of course. Yes, thank you. See in a minute why I do tangent. Tangent is 18 over 24. On the other hand, tangent is the ratio of this to this, is equal to y over 24 minus x. So what I did, I found this relationship between x and y. In other words, I can say that y is equal to 24 minus x times 18 divided by 24. 18, that's 3, that's 4. So y is 3/4 of 24 minus x. Y is 18 minus 3/4 x, which will come in very handy. So the area of the rectangle is x times y. So that's x multiplied by y, which is 18 minus 3/4 x. How well do you understand what I've done so far? Please let me know on a scale of 0 to 10. Okay. So I use tangent. I hope you understand how I use tangent. I said tangent is 18 over 24, so it's the opposite divided by adjacent. But it's also equal to y over 24 minus x. So then I just expressed y in terms of x. Then area is x times y, this area, and it's x times this. In other words, that's 18 minus 3/4 x squared. So if we draw this graph, of area, so area versus x. So if x is 0, area is it's 18x, sorry. If x is 0, area is 0, obviously. And if x is 24, it's also 0. And somewhere in between, there's a maximum value. 0, x. Yeah? Because that's how it is. The area is a function of x. And when x changes, the area changes. If x is 0, the area must be 0. And if x is 24, not from here, but from here, from this graph, I can see that if x is 24, then the area is going to be 0. Because if x is 24, the rectangle looks like this with the 0 area. So what we need to do? Well, we need to find the derivative. Exactly. Thank you. It's maximum when the derivative dA over dx is 0, or when a prime is 0. So a, now we find a prime, the derivative of area is 18 minus, so 3/4 multiplied by 2x. 18 minus 3 over 2x. And this a is max when a prime is 0. So 18 minus 3 over 2x is 0. Could be 3 over 2x equals 18. X is, as a matter of fact, it is 12. Well, yeah, you can use different reasoning why x is 12, but yeah, X is 12. When X is 12, the area is maximum. And that's how you do it. And if you, this is called an optimization problem. They do this in economics all the time. Okay. For example, if you, just a simple example from economics, you have the price, you have the price, P is price, and Q is quantity. Now quantity is how much you can sell. Yeah. So typically the quantity is a function, something like 2000 minus, okay, let's keep it simple. 200. Let's say you're selling cars. Okay, you're selling cars. This is P is the price of your car. Q is the quantity minus 0.2 times P. Okay. Price in, I don't know, thousands of pounds or something like this. That means the higher the price, the less cars you will sell. Yeah. So if price is 0, so you will sell 200 cars. That's all the cars that you have. If price is 1,000, you will sell 0 cars. Okay. Your revenue is the price times the quantity. How many, what price times the quantity. So in both those cases, your revenue is 0. So you won't sell cars for 1,000 whatever, 1,000 Bitcoin, because nobody will buy them, and then you go bankrupt. And you won't sell them for 0 because then you will go bankrupt. You need a sweet spot. And how to find this is you find the revenue. Revenue is price times quantity, which is price times 200 minus 0.2 price. It's 200 P minus 0.2 P squared. Then you find the derivative. It's 200 minus 0.4 P, and that must be equal to 0. And your 0.4 P equals 200. P is 200 divided by 0.4, which is what? 500. 500. Let's say it's 1962, and you can sell cars for 500 pounds. That's how much a car was in 1960s. Yeah, so that's your price, which if this method is used, why are so many things worth multiples of 5 or 1 less than a multiple of 5? This is, yeah, it's a little bit more complicated than that, because people tend to buy, tend to look at the price, and there's a psychological element to it. Like 45 sounds like it's closer to 40 when it's not closer to 40. 49.99 the price. But yeah, this is an ideal situation. This is like like economists and business studies, they also deal with spherical horses in a vacuum. Yeah, so this is an ideal situation. Of course, there are some other factors at play. It's not as simple as that. Otherwise, any first-year graduate students would be able to be the CEO of a huge company. It's a little bit more complicated than that, but this is a rough way of doing stuff. It's called an optimization problem. You're optimizing the quantity of stuff you want to sell in order to get the maximum profit or maximum revenue in this case. Anyways, hope that was useful. And I'll see you next week. See you next week with some more physics and maths. I'll probably do a mixed next week. Haven't decided yet, but yeah. You're welcome. See you.